Okay, to find I, either you can say, yes, it's the parabola x squared is 4ay, so y is x squared on 4a. dy dx, therefore, differentiating that is 2x on 4a, which is x on 2a. Remember, we're trying to find the equation of the tangent at P. To do that, always for equation of tangent, you've got to differentiate to find the gradient of the function. Now, you can do that this way, or you can do it, you know how I've shown you this way, but I've also shown you this way. X is 2at, y equals at squared, dy dx is dy dt times dt dx. You remember that? Where you work it out, but t is p, or you could have done it this way. Now, we've done it heaps of times before. So if you want, you can do that x squared is 4ay, so y is x squared on 4a, dy dx is x on 2a. Gradient of the tangent at P is where you substitute the point P, the x value at point P, which is 2AP. So the gradient of the tangent at P is P. We've done this a few times now. Equation of tangent, y minus y1 equals mx minus x1. Do you remember this? Y minus AP squared is px minus 2AP squared. So I've rearranged that to make y the subject. We okay with this? Did anyone try it on their own yesterday? Or just no time? All right, then that's the equation of the tangent at P is equation 1. Equation of tangent at Q is identical. Can you see that okay? It's a bit blurry. Yeah, but they're all dots all over it. It's the board. Equation of tangent at Q is y equals qx minus aq squared. You want I is the point of intersection of those two. Do I need to have a quick sketch of this, girls? You know, you've got P and you've got Q. Yep. And I, that's the gradient of the tangent at P, gradient of the tangent at Q, and I is the point of intersection. You're pretty comfortable with P is 2AP AP squared now. Q is 2AQ AQ squared. Point of intersection is to solve simultaneously. So y equals that and y equals that, so put them equal to each other. Girls, you're trying to solve x and y. Jin, I've got your little thing here, which I'll give back now. Yesterday I said I was going to steal it, but I didn't mean it. So girls, equation 1, equation 2, putting them equal to each other. Because you're trying to solve for x, you take anything with x over to the left, anything without x is on the right. Factorize out the x so it appears only once. And then you'll actually, you shouldn't cross out like that, but I'm really dividing both sides by p minus q. You don't actually cross them out like that. You divide both sides by p minus q, and you will end up with x is a bracket p plus q. You okay with it? Where's Gloria? All right. We substitute x is that into equation 1 up there. Because we've done, you're okay with equation of tangents. Point of intersection is to solve simultaneously. Okay, substituting it into equation 1, putting x is that into equation 1, you'll end up with p, pa. You okay with that? P plus q, expanding it. Can I move down a bit? I don't even know what the questions are. No. You've got to show that, question 16b, show that MT and I lie in a vertical line with T the midpoint of MI. So, over here, what was T again? The I was the intersection of the tangents. What was T again? Can't remember what T was. T is the point on the parabola where the tangent is parallel. There we go. T was like this point here. So girls, M, T and I, what do you notice about them? They're down here. They've all got the same x value. So you'll say M, T and I all have the same x value, because I've just written them there again. So M, T, and I all have the same x coordinate or whatever. So M, T, and I have the same value for x coordinate, therefore lie in a vertical line. Therefore they lie in a vertical line. You okay with that? All right, and now girls, I'm sure that, what are you going to do now to show that T is the midpoint of MI? Girls, if they're above each other, you don't do distance formula, isn't it? You just have to subtract the y values. So girls, we want to do the distance MT. So won't it be this M value minus that M value? And I, for some reason, have done it the other way around. Isn't M above T? Why have I done that? So, MT. M is the midpoint of... All right, so let's do it. MT, what is it? I hope I've written these the right way, girls, have I? Because I have a feeling I... Is that right? Can you just go back and see what I'd done yesterday? Yep. Okay. So MT will be A bracket P squared plus Q squared over 2 minus A over 4. Is that right? P plus Q all squared. Now, girls, we're not going to be able to add or subtract anything like that until the denominators are the same. So what should I do? Girls, this fraction's over 2, this one's over 4. What'll I do? Multiply this fraction by 2 on 2. So I get 2A bracket P squared plus Q squared over 4. Now it's all going to be over 4 minus A bracket P plus Q squared. You okay with this, girls? Both fractions are over 4. Be careful when you expand. The first one you're just multiplying through 2AP squared plus 2AQ squared. But what's the second one? A perfect square. It's not P squared plus Q squared. What is it? Minus A times what? P squared, come on, plus 2PQ plus Q squared. It's a perfect square. All over 4, which means it's 2AP squared plus 2AQ squared minus AP squared minus 2APQ minus AQ squared. Wait a sec. So we've just expanded that out. Over 4. Anything cancel? What do you get? 2AP squared minus AP squared is AP squared. 2AQ squared minus AQ squared is plus AQ squared. So minus 2APQ all over 4. Which is, look, you can just make it, take out the A from everything, I think. Yeah, A bracket, P squared plus Q squared minus 2PQ. That's looking very familiar. Girls, I took an A out from everything. What do you notice that this is? What does that look like? That's a perfect square. A bracket P minus Q squared on 4. Do you see that? That's P squared minus 2PQ plus Q squared. That's a perfect square. We took out an A. That's what MT is. Now let's do, if T is the midpoint of MI, we're trying to show that just one sec, that T is the midpoint of MI. So, oh yes, thank you very much. Yeah, I am so, thanks a lot. Now I'm recording. No, she's right. Girls, to show that T is the midpoint of MI, it's easier just to do the midpoint of MI and show that it's T. I'm so sorry. I'm just a bit tired. I'm going the long way and doing the distance MT and the distance MI. Really sorry. If you want, you can finish that and do the distance TI, sorry. To show that T is the midpoint, you can either find MT and TI and show that they're the same, or the much better way to do it would be just do the midpoint, I'm really sorry, of MI. Wouldn't that be better? All right, midpoint of MI. Isn't it add the X values together, divide by 2? Sorry, girls. So how am I going to fit all that so I can see it? All right, so we've got midpoint of MI. Add the X values together. Divide by 2. Add the Y values together. Look, I can see them here. I'll just do them. Thanks a lot. Oh, this is actually going to be... Actually, it's going to get a bit messy. Look, girls. Shh, shh, shh. Girls, they're the X values being added together. Divide by 2. Shh. These are the Y values. So the first Y value is that. The second Y value is APQ, and dividing it by 2, you've got fractions over fractions. So, what's this? Girls, are they like terms? What is it? 2A bracket P plus Q over 2. Girls, what's halfway between A P plus Q and A P plus Q? If I say to you, what's the average of 7 and 7, what would you tell me? What's the average of AP plus Q and AP plus Q? AP plus Q. You know, like if you got 7 in a test and 7 in the next test and you want to do the average, you go 7 plus 7 is 14, divide by 2 is 7. If you do the average of 2 identical things, you get the same number. So if I want to do the average of the X values, which is A bracket P plus Q and A bracket P plus Q, the average of those two will be A bracket P plus Q. But I can do it and I'll say that's 2 lots of A bracket P plus Q. I do get A bracket P plus Q. Now, this is the Y value for M and the Y value for I. How are you going to add those two together? You'll need a common denominator. So what I'm going to do, going to do a common denominator for these for the numerator. So how do I do that? AP squared plus AQ squared plus 2APQ over 2. And if you now divide, that's the top row, the numerator. If you divide that by 2, where does that 2 go? Divided by 2 is the same as, I'll go divide by 2. So what's it going to be? AP squared, I'm going to factorize out an A. A bracket P squared plus Q squared plus 2PQ. Instead of divide by 2, it's times a half. What do I put this over? Tape. Girls, it's all of, I just expanded that and made this with a denominator of 2. Yeah, so it's all over 4. Because it was all of that over 2, then divided by this 2, which is the same as times a half. So, I've got A bracket P plus Q. What's this? What's a perfect square with a plus. Now, is that the coordinates of T? Yes. Which equals T. So therefore, therefore T is the midpoint. Sorry about that. Oh well, you'll know not to do silly things like what I'm doing. I don't know why I was doing that. Okay. Are you okay with that? So midpoint of MI happens to be the point T. That's done. Show that the tangent at T bisects the tangents PI and QI. Oh my goodness. All right. I'll just show you what that's all about, but I don't think we're going to do it, all right? Just too much work. You ready? The question for part C, are you ready, girls? Can I move? I want to show you part C, and it says this. Show that the tangent at T bisects PI and QI. Look, here's the diagram. Show that this one. Okay. It says show that the tangent at T, which is this one, bisects PI and QI. You're going to have to show that P to that distance there equals that, and that this distance to there equals this one. Now, you know what, how are you going to do that? We don't even know what those points are. Why don't we just, do we have the equation of the tangent at T? We do. Don't we have the equation of the tangent at T? Girls, that question takes too long. You'd either have to solve simultaneously the gradient of the tangent at T with that at P. It's too much work. Too much work. We're not doing it. All right? Let's just leave the rest. We're not doing any more. A little heading, chord of contact, exercise 9H. Now, what is the chord of contact? So, you just learn this formula, girls. This is one formula you want to learn. Yep, copy that box. All right, instead of P and Q, I don't know why they're calling it XY, but they're calling it XY. So, the equation of the chord of contact XY of tangents drawn from an external point X1, Y1 to the parabola at X and Y is given by this: X times X1 equals 2A, Y plus Y1. So just copy that all down. Now the chord of contact is XY. So if you have an external point P and you draw a tangent to the parabola at Y and a tangent from P to the parabola at X, XY is called the chord of contact. So it's a chord of the parabola, but it's called the chord of contact. So from an external point, tangents drawn from an external point to a circle are equal. They're not equal for a parabola, all right? So these are two tangents drawn from an external point. Can you see when I work? No, you can't. I'll use my mouse. Okay, girls, see from point P to Y, that is a tangent from the external point P to the parabola Y. And from point P, we have a tangent drawn to the point X from this external point P. Now, in circle geometry, you learn tangents to a circle from an external point are equal. It's not the case with parabolas. Px does not equal Py. All right, but what we've got here in this box is the equation of the chord xy. And it's called the chord of contact because it goes from the point of contact of the two tangents. Okay, so it's not the equation of Px or the equation of Py that you're getting. We know how to do equation of tangent. All right, Py is just the equation of the tangent at y. Px is the equation of the tangent at x. Xy is the chord of contact, and that's the formula for it. X times x1 equals 2a y plus y1. Okay, now, we might just go straight in and do a question. Now, how do they prove it? Do you want to write it down? Oh, you know what they've done, girls? You've seen this many, many times, but if x is 2ap, ap squared, and y is 2aq, aq squared, you know how we've found the equation of the chord many, many times? And we've ended up with this, y equals y minus half. You can just watch. You don't have to write it down. P plus qx plus apq. That is found. They've done that by doing, how do you find the equation of the chord xy normally? Just gradient and then point gradient formula. So that's got nothing to do with tangents. So that's what they've done there. You don't have to copy it. You can do it later. Yeah, just copy the diagram quickly. So what they've done is they've found the equation of the chord xy. Can you come back and get that diagram? And then, because the tangents at x and y intersect at the point x1, y1, but the intersection of the tangents, now, you know how we've done many questions, and we have done intersection of tangents. From previous stuff, we've done we found that the intersection of the tangents is, actually we just did it in question 16. A bracket P plus QA PQ, we've done it. We just don't want to do it all again. Therefore, X1 is this point here, A bracket P plus Q, and Y1 on the diagram is APQ, and then I think they're just substituting it in. All right, but you don't have to know it. All right, so what we're going to do is we're just going to do an example. Okay, so if you copied this down, don't worry about the proof. Let's just do some examples. Copy it down and we'll do some examples. Question 8. Find the equation of the chord of contact. We're just going to keep the questions really simple here because that's all they ever are for this one. Find the equation of the chord of contact of the parabola x squared equals 8y from the points 2, 0, and we're also going to do it from another point Q, which is 1, negative 1. Okay, so question 8a. Find the equation of the chord of contact of the parabola x squared equals 8y from point P and from point Q. What's the equation? Equation of chord of contact is x times x1 equals 2a y plus y1. Now, what's x1 and y1? What's x? X1 is 2. What's y1? And what's a? Look at your parabola. X squared is 4ay. So a is? So we know that x squared is 4ay. X squared is 8y. Therefore a equals 2. So let's do our chord of contact. So x times what? So this is my bit of working out. That's my equation. So x times what? What's x1? So x times 2 equals what? 2 times 2, y plus 0. So 2x is 4, what? Oh, you can't see that. 4 what? 4y. So therefore, we don't like to leave it like that. Dividing everything by 2, x is 2y, or y equals x on 2. It's just a straight line. You know, the chord is just a... Okay? Now, can you do the equation of the chord of contact from this point? So x1 equals 2a, y plus y1. What do we substitute in? Do you know what to do? It's not hard, is it? It's easy. X times what? What's x1? Equals 2 times, a is 2, you know. Same question. A equals 2, y plus negative 1. X is what? 4y plus negative 1. What? Minus 4. So 4y is x plus 4. Okay? Keeping the 4y there, taking. And so therefore y is x on 4 plus 1. Dividing. It is. It's x1 equals 2a y plus y1. All right, so we've got two equations there. So girls, here is my parabola, x squared equals 8y. It doesn't matter. You know why I'm doing it like that? So I can see focus of the parabola would be 2. I don't know, one line looks like this, and the other line looks a bit flatter. They're two separate things. But the chord... All right. All right, I'll show you. All right, the first point, external point, is 2, 0, which is here. So the chord of contact is you draw a tangent there and a tangent there, and it's this line between the two tangents. So this is point P. There's my parabola. From point P, you do a tangent there and a tangent there. I'm not saying my parabola is drawn very accurately. And this is the chord of contact. So it's got the equation y equals x on 2. Shh. The second graph, x squared equals 8y. The external point, girls, is 1, negative 1 down here. Shh, girls. And a tangent's drawn to there. And let's say a tangent's drawn to there. That is the chord of contact. Girls, please. Girls, do you get the idea? Here's point Q. A tangent's drawn to the parabola there. A tangent's drawn to the parabola there. This blue one here is the chord of contact. It has equation y equals x on 4 plus 1. This is point P. Draw a tangent to the parabola there and there. This black line here is the chord of contact, what we did in part 1 up there. Do you get the idea? It still is a chord of the parabola, but it goes from the endpoints of the tangents from the external point. Now, they're your two equations, and part B says that if, so I've just drawn them there, if the chords of contact intersect at R, and I haven't drawn them on one diagram, show that PQ is a tangent. So, if the chords of contact intersect at R, show that PQ is a tangent to the parabola and that its point of contact is R. Oh, God. So, part B, if the chords of contact intersect at R, so I've drawn both the chords of contact there, y equals x on 4 plus 1. Here is the other blue one, y equals x on 2. If they intersect at R, it says to show that PQ is a tangent to the parabola. Well, P was the point 20, so I'll say it's about there. And R is the, and Q is the point, say, 1, negative 1. Now, girls, I have not drawn this to scale. So it says, show that PQ is a tangent to the parabola and that its point of contact is R. Point R, it's the intersection of the two chords of contact. We're going to solve y equals x on 2 and y equals x on 4 plus 1 simultaneously. All right, so let's go. Girls, I shouldn't have drawn that. Maybe my drawing's not very good. Do you know what I mean? So, all right, one sec. So how do I solve them two simultaneously? Well, equation 1 and 2, x on 2 equals x on 4 plus 1. What are you going to do now? So if the chords of contact intersect at R, you've got the chords of contact. Let's find the point of intersection, all right? Times through by? Yep, so you get 4x on 2, which is 2x, equals x plus 4. In other words, x is 4. You know what? I have a feeling my diagram's not very good, and that's why we're not getting this. So, just leave that. Because I went minus x, 2x minus x. So when sub x is 4, when x is 4, girls, what's y? Y is 4 on 2. Is that good enough? Which is 2. So I'm going to draw this on a page. All right? Don't worry, I've got it there. Here we go. All right. I'll lift it. There you go. Now let me draw it. You know what? It's the parabola x squared equals 8y, and I'm trying to draw this, but you know, I haven't even drawn it to scale, so I might just try and draw it to scale. So when x is, say, 4, what would y be? X is 4, you get 16, what's y? So let me try and draw it to scale a bit. And when x is, say, 2, what's y? A half. All right, now this is what I'm going to do. I might have a better chance if this parabola is actually drawn to scale a bit. We had the points 2, 0 and 1, negative 1, didn't we? And what is the point R? We've just found it out. Now I can see it. R is 4, 2, and guess where 4, 2 sits on? The parabola. And you know what? Now the question makes sense. So there's P and Q, and they pass through the point of intersection of the two chord of contacts. So if I draw y equals x on 2, when x is 2, y is 1. When x is 4, y is 2. That's one chord of contact. And the other chord of contact is that one. There you go. So girls, this is the point P and that's the point Q. Now, I've just found what R is. I've just got to show that PQ, the question is, if the chords of contact intersect at R, which we've done, show that PQ is a tangent to the parabola and that its point of contact is R. What do you think we should do with PQ? Find its equation. And if PQ is a tangent to the parabola, when you solve the parabola with the tangent and you put them equal to each other, shouldn't I only get one solution? All right, so let's just find the equation of PQ. So first we find the gradient of PQ. Girls, these are just numbers. All right, gradient of PQ, what is it? Gradient of PQ. Isn't it y2 minus y1 over x2 minus x1? All right, girls, so let's do the equation of PQ. First gradient, 0 minus negative 1 over 2 minus 1 is 1. Got it? What about the equation?
Could Isabella Contreras, please come to the school office? Thank you.
Equation of PQ is y minus, let's use the point 2, 0. Y minus 0 equals 1, x minus 2, y equals x minus 2. Now, if PQ is a tangent, so if PQ is a tangent, then PQ touches x squared equals 8y only once. Do you know what I mean? It's a tangent. So if you solve, so we want to solve y equals x minus 2 and x squared equals 8y simultaneously. But you know what, girls? You actually don't have to. Oh, we will solve it. You know why? Because we're going to show that R is the point of contact. Do you get what I'm doing? We've just found the equation of PQ, just using normal numbers, like its normal method. If PQ isn't a tangent, it will only touch that parabola once. So solve where does the line y equals x minus 2 and the parabola, solve them simultaneously. Why don't we just get x squared is 8 by substitution, girls? Bracket x minus 2. X squared is 8x minus 16. How do we solve that? Bring it all over to the left. Perfect square. X is 4. We already know that it touches. We've already drawn it. And when x is 4, what's y? Y is 4 minus, well, actually, you'd use, I drew it before. So the girls, therefore, the tangent cuts the parabola at the point 4, 2, and the point 4, 2 happens to be the intersection of the two chords of contact. So therefore, we've proven what we were meant to prove. We did point R because point R was where the chords intersect, and point R is also where the tangent to the parabola meets the parabola. All right, girls. Okay. Exercise 9F, questions 9A, 10 and 12. Exercise 9H, chord of contact, questions 7 and 9. You know what? Do you want to add another one to that? And 6. Question 6, 7 and 9, I changed my mind. I'm sending a video anyway.
Question 7, 9.
6, 7 and 9. It looks good.
7.
You just look at the video. It's at the end of the video if you're not sure.